How do you know something bad will happen in horror movies? You know it because the light starts flickering without a good reason, and not because an idiot switched it on and off really fast. So in this Halloween episode, I will show you how I hacked this normal LED light bulb into a realistic flickering one for your Halloween party or to scare your friends. Let's get started. First of all, let's take a look at our light bulb. As you can see, the packaging is horrible, but I chose this cheap one from China for a good reason. Because when I try to open it, I don't even need force to unscrew the front and the back of the bulb. Here's a comparison to a pretty high quality LED bulb from LG, and it is not possible to get inside without destroying the whole thing. So get a cheapie. For testing purposes, I will use the socket with exposed connections. I used my suicide AC wire here and just hooked the wires up to my socket. But that is really dangerous. Remember, I am playing with 230 volts, which can kill me. So for safety reasons I covered the connections with electrical tape. Now just a quick test and great, it lights up. I unscrewed the top cover and there you can see the power connections for the LEDs. Just a quick measurement here and we can see that those LEDs get around 23 volts DC. That means there must be a power supply inside, right? And yes, there is one inside, which makes things easier. Okay, switching DC current on and off is really easy with a MOSFET. Here I have the bus 11, which can handle voltages up to 50 volts and 30 amps, so it'll work. At first I used the Arduino Uno as the testing microcontroller, and since an N-channel MOSFET can only connect the LED to ground, I desoldered the ground wire of the LED from the power supply. Here's the schematic for the test. I used the PWM pin 3 of the Arduino to generate random voltage values which will control the gate of the MOSFET, and this should let the bulb flash randomly. After everything is hooked up, it is time for a test, and I hope that nothing blows up. And yeah, it works just as I thought it would, but the Arduino doesn't really fit inside the bulb. So let's use an AnyTiny 85 to shrink it down a bit. I just changed the PWM pin to pin 0 and used my homemade programming shield to program the AnyTiny. Check out my other video if you don't know how that works. And I also used a 5V regulator to generate nice 5 volts from the 24V power supply. Here's the schematic for the final design. But firstly, let's test it on the breadboard, because testing is always important. And it still works just fine. Time to make it small. I soldered the 100 nF moving capacitors directly to the LM7805. I cut the not used pins of the AnyTiny and soldered the 10K pull-up resistor from reset to VCC. And I soldered the 10K pull-down resistor between gate and source of the MOSFET. The rest is just annoying precise soldering with this thin wire to connect all the parts like they were connected on the breadboard. Okay, that looks nice. Give it power and it still works. Let's seal the deal with hot glue, because I do not want that pins touch each other inside the small case, which could lead to damages. And I also used electrical tape to isolate the MOSFET body and the voltage regulator body. I stuffed everything inside the case and made one final test to confirm the functionality. Now it is time to scare your friends, or whoever, by replacing the regular light bulb with this modified one. When he will come home, he will just think, nope, 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 I'm moving out. And that was my Halloween video. I hope you liked it. Maybe you subscribe? Definitely check out my Instructable site for more awesome projects, with more information handwritten by me. And also check out my Facebook, Twitter and all that social media stuff. Stay creative and I will see you next time.